All right, everyone, welcome back. Today, we're diving into something that separates the pros from the amateurs in our industry: building investment decisions. Now, I know what you're thinking. Great, more math. But trust me, this is the fun kind of math. The kind where you get to figure out if spending money today will make you rich tomorrow, or if you're just throwing cash into a very expensive bonfire. By the end of this lecture, you'll be able to walk onto any construction site or into any boardroom and actually understand why your boss is sweating over whether to buy that new excavator or stick with the rusty one that sounds like a caffeinated squirrel. Let's get started. So, what are we actually learning today? 4 key things. First, we're going to master the concept of the time value of money. And no, this isn't some philosophical discussion about whether money buys happiness, though I can tell you that a well-timed investment decision definitely helps. Second, you'll learn how to evaluate different investment opportunities, because in the real world, you can't do everything. You've got limited resources, and you need to pick the winners. Third, we're tackling payback period and discounted payback period. Think of this as answering the question, when do I stop bleeding money and start making it? And finally, net present value, or NPV. This is the king of investment analysis tools, and once you understand it, you'll never look at a project proposal the same way again. Ready? Let's go. Okay, here's a question for you. Would you rather have $100 today or $100 a year from now? If you said today, congratulations, you understand the time value of money. If you said a year from now, we need to have a serious conversation about your life choices. Here's the deal. Money available right now is worth more than the same amount in the future. Why? 3 reasons. 1. Opportunity cost. That $100 today could be invested. You could put it in a savings account, buy stocks, or even invest it in better tools for your construction business. A year from now, that 100 could be $105 or $110. 2. Inflation. Remember when your parents told you they bought their first car for like $3,000? That same car today would cost $30,000. That's inflation eating away at the purchasing power of money. Your $100 next year won't buy as much as it does today. 3. Risk. A bird in the hand is worth 2 in the bush, as they say. Money promised in the future comes with uncertainty. What if the project fails? What if the client goes bankrupt? Cash today is certain. Cash tomorrow is a maybe. This is why we discount future money when making investment decisions. We need to compare apples to apples, or, in our case, today's dollars to today's dollars. Now let's get into the mechanics. The present value formula is your best friend in investment analysis. Here it is. PV equals FV divided by 1 plus R to the N. Let me break this down. PV is present value, what future money is worth today. FV is future value, the amount you'll receive in the future. R is the discount rate or interest rate. This is your opportunity cost. N is the number of periods, usually years. Think of this formula as a time machine for money. It takes future dollars and converts them into today's equivalent. Here's an example. Let's say a client promises to pay you $10,000 in 2 years and your discount rate is 5%. What's that worth today? PV equals $10,000 divided by 1.05 squared. PV equals $10,000 divided by 1.1025. PV equals $9,070.29. So that $10,000 promise is really only worth about $9,000 in today's money. That difference? That's the cost of waiting. That's why we discount. Of course, the formula works both ways. Sometimes you need to know, if I invest this money today, what will it be worth in the future? That's where future value comes in. FV equals PV times 1 plus R to the n. Same variables, just rearranged. So if you invest $5,000 today at 6% annual return for 3 years, FV equals $5,000 times 1.06 the cube. FV equals $5,000 times 1.191. FV equals $5,955. Your $5,000 grows to almost $6,000. Not bad for doing absolutely nothing except waiting. Although in construction, we're rarely doing nothing. We're usually putting that money to work in equipment, materials, or labor. Now, here's where things get interesting. And by interesting, I mean where people argue in boardrooms. How do you choose the right discount rate? The discount rate represents your minimum acceptable rate of return. It's what you could earn if you invested that money elsewhere. Think of it as your opportunity cost. Common approaches. 1. Use your company's cost of capital. If you're borrowing money at 7%, well, you better earn more than 7% on your investment, or you're losing money. 2. Use the rate of return on alternative investments. If you could safely earn 5% in bonds, any construction project should beat that. 3. Add a risk premium. Riskier projects need higher returns to be worth it. A government contract might use 8%, but a speculative development might need 15% or 20%. Here's the kicker. A higher discount rate makes future cash flows worth less today. So if you're trying to justify a sketchy project, you might be tempted to use a low discount rate. Don't be that person. Use realistic rates, or you'll be explaining to your boss why you lost money on what looked like a sure thing. All right, let's look at a real-world scenario. Imagine you're running a construction company, and you're considering buying a new piece of equipment, let's say a fancy excavator. Here's the situation. The excavator costs $400,000 up front. It'll generate additional revenue, or save costs, over its useful life. Let's say it produces cash flows of $100,000 per year for 5 years. Your discount rate is 10%. The question, is this a good investment? Your gut might say, well, I'm paying $400,000 and getting back $500,000 total, so that's good. But wait, we need to account for the time value of money. Those future cash flows aren't worth their face value in today's dollars. This is where our analysis tools come in. We've got several ways to evaluate this, and, spoiler alert, they don't always agree with each other. Let's start with the simplest one. The payback period answers one simple question. How long does it take to get my money back? For our excavator, year 0, spend $400,000. Ouch! Year 1, get back $100,000. Cumulative, negative $300,000. Year 2, get back $100,000. Cumulative, negative $200,000. Year 3, get back $100,000. Cumulative, negative $100,000. Year 4, get back $100,000. Cumulative, $0. Payback period equals 4 years. So in 4 years, you've recovered your initial investment. Anything after that is pure profit. Now, is this good or bad? Well, that depends on your company's policy. Some companies say, we want payback in 3 years or less. Others are fine with 5 years. But here's the problem with payback period, and it's a big one. It completely ignores the time value of money. It treats $1 in year 1 the same as $1 in year 4, which we know is wrong. It's like saying, a pizza today is the same as a pizza next week. Sure, they're both pizza, but I'm hungry now. That's why smart companies also look at the discounted payback period. This is the payback period's smarter, more sophisticated cousin. Instead of using the actual cash flows, we discount them to present value first. Let's recalculate for our excavator using that 10% discount rate. Year 0, minus $400,000. No discounting needed, it's already today. Year 1, $100,000 divide by 1.10 to the power 1 equals $90,909. Cumulative, minus $309,091. Year 2, $100,000 divide by 1.10 squared equals $82,645. Cumulative, minus $226,446. Year 3, $100,000 divide by 1.10 to the cube cured equals $75,131. Cumulative, minus $151,315. Year 4, $100,000 divide by 1.10 to the fourth cured equals $68,301. Cumulative, minus $83,014. Year 5, $100,000 divide by 1.10 to the 5 cured equals $62,092. Cumulative, minus $20,922. Uh-oh. Notice something? We never fully pay back the investment when we account for the time value of money. Even after 5 years, we're still about $21,000 short. This is a much more realistic picture. The regular payback period said, "Great investment." The discounted payback period is waving red flags. This is why the choice of analysis method matters. It can literally be the difference between a profitable decision and a money pit. Now we come to the heavyweight champion of investment analysis, net present value, or NPV. NPV asks, if I discount all future cash flows to present value and subtract my initial investment, what's left over? The formula, NPV equals sum of all discounted cash flows minus initial investment. Or, more formally, NPV equals sigma minus initial investment. For our excavator, we already did most of the work. Year 1 PV, $90,909. Year 2 PV, $82,645. Year 3 PV, $75,131. Year 4 PV, $68,301. Year 5 PV, $62,092. Total PV of cash inflows, $379,078. NPV equals $379,078 minus $400,000 equals negative $20,922. A negative NPV. This means the investment destroys value. The decision rule is beautifully simple. NPV 0, accept the project. You're creating value. NPV 0, reject the project. You're destroying value. NPV equals 0, you're indifferent. You're exactly breaking even in present value terms. In our case, that excavator looks like a bad investment. You'd be better off putting that $400,000 into almost anything else that earns 10%, even a boring index fund. So why do we love NPV so much? Several reasons. First, it accounts for the time value of money. Unlike simple payback period, it recognizes that $1 today is worth more than $1 tomorrow. Second, it considers all cash flows over the entire life of the project. Payback period ignores everything after payback. What if our excavator lasted 10 years instead of 5? Payback period wouldn't care, but NPV would. Third, it gives you a dollar amount of value created or destroyed. It's not just yes or no, it's this creates $50,000 of value, or this destroys $20,000 of value. Fourth, NPVs are additive. If Project A has an NPV of $100,000 and Project B has an NPV of $50,000, doing both creates $150,000 in value. Try doing that with payback periods. That said, NPV isn't perfect. It requires you to estimate future cash flows, which, let's be honest, is part science, part art, and part wild guessing. And it requires choosing the right discount rate, which we saw can be controversial. But it's still the best tool we have for most investment decisions. In the real world, you're rarely looking at just one investment. Usually, you've got multiple options and limited money. Maybe you can buy the excavator, or a new dump truck, or upgrade your office software, but not all three. This is where NPV really shines. Let's say you have 3 options. Option A, excavator. NPV equals negative $20,922. We calculated this. Option B, dump truck. NPV equals $45,000. Option C, crane. NPV equals $32,000. The ranking by NPV: 1. Dump truck, $45,000. 2. Crane, $32,000. 3. Excavator, negative $20,922. If you can only pick one, choose the dump truck. It creates the most value. But wait, What if you have enough money for 2 investments? Then you'd pick the dump truck and the crane, creating $77,000 in total value. This is called capital rationing. You're allocating limited capital to the best opportunities. Here's a pro tip. Sometimes companies get this backwards. They'll buy the cheapest option because we can afford it, even if it has a lower NPV. Don't fall into this trap. Buy the option that creates the most value, even if you have to finance it. Unless, of course, the NPV is negative. Then you buy nothing and save yourself a headache. Now, here's where experienced construction managers earn their keep. Sensitivity analysis. Remember when I said NPV requires estimating future cash flows? Well, those estimates could be wrong. Maybe the excavator generates $120,000 per year, not $100,000. Or maybe it only generates $80,000. How sensitive is our decision to these estimates? Let's test our excavator investment. Base case, $100,000 per year for 5 years. NPV equals minus $20,922. Optimistic, $120,000 per year for 5 years. NPV equals $454,893 times 1.2 minus $400,000 equals $54,876 positive. Pessimistic, $80,000 per year for 5 years. NPV equals $454,893 times 0.8 minus $400,000 equals minus $96,786. Very negative. Whoa! A 20% change in annual cash flow swings our decision from reject to accept in the optimistic case. This tells us our decision is quite sensitive to our revenue estimates. In situations like this, you need to 1. Do more research to nail down those estimates. 2. Consider the probability of each scenario. 3. Maybe look for ways to reduce risk, guarantees, contracts, hedges. Smart construction managers don't just calculate one NPV, they calculate several, understand the range of outcomes, and make informed decisions based on their risk tolerance. Before we wrap up, let me introduce you to NPV's cousin, Internal Rate of Return, or IRR. IRR answers the question, what discount rate makes the NPV equal to 0? In other words, it's the break-even rate of return on the investment. For our excavator, the IRR would be the rate R, where $400,000 equals $100,000 divided by 1 plus R to the 1, plus $100,000 divided by 1 plus R squared, plus $100,000 divided by 1 plus R 3, plus $100,000 divided by 1 plus R through 4th, plus $100,000 divided by 1 plus R to 5th. This usually requires a financial calculator or spreadsheet, but for our example, the IRR is approximately 7.9%. The decision rule. If IRR discount rate, cost of capital, accept. If IRR discount rate, reject. In our case, IRR is 7.9%, but our required return is 10%, so we reject. Same conclusion as NPV. IRR is popular because people like percentages. 15% return sounds cooler than $50,000 NPV. But be careful. IRR can be misleading with non-conventional cash flows or when comparing projects of different sizes. My advice? Calculate both NPV and IRR. But when they disagree, trust NPV. Let me save you from some rookie mistakes I've seen over the years. Mistake number 1. Ignoring sunk costs. If you've already spent $50,000 on a project, that money is gone. Don't throw good money after bad trying to recover it. Only consider future costs and benefits. Mistake number 2. Forgetting about working capital. That new equipment might require more inventory, more spare parts, more everything. Don't forget these costs. Mistake number 3. Being overly optimistic with cash flow estimates. I call this the best-case scenario bias. Everything goes wrong in construction. Plan for it. Use realistic, even conservative estimates. Mistake number 4. Using inconsistent assumptions. If you're using 10% discount rate for one project and 5% for another, you're not comparing fairly. Mistake number 5. Ignoring taxes and depreciation. In the real world, Uncle Sam wants his cut. After-tax cash flows are what really matter. Mistake number 6. Forgetting maintenance and operating costs. That excavator needs fuel, maintenance, insurance, and an operator. These aren't free. Mistake number 7. Analysis paralysis. Yes, analyze thoroughly. But at some point you need to make a decision and move forward. Perfect information doesn't exist in construction. Let's bring this home to construction specifically. You'll use these tools to evaluate equipment purchases. Should we buy or lease that excavator? Technology investments. Is that new project management software worth it? Process improvements. Will a new prefabrication facility pay off? Building designs. Does the extra cost of sustainable features provide enough long-term savings? Bidding decisions. Should we invest in pursuing this large contract? Here's a real example. A company is deciding whether to invest in 3D modeling software and training. Upfront cost, $150,000. Annual savings from reduced rework and better coordination, $45,000. Useful life, 5 years. Discount rate, 12% NPV, equals $45,000 times divided by 0.12, $150,000 NPV, equals $45,000 times 3.605, $150,000 NPV, equals $162,225, $150,000, equals $12,225. Positive NPV. The investment is worthwhile, even though the payback period is over 3 years. This is how you build a business case for any investment in your construction company. All right, let's wrap this up. What did we learn today? 1. Money has a time value. $1 today is worth more than $1 tomorrow because of opportunity cost, inflation, and risk. 2. We use present value and future value formulas to compare cash flows occurring at different times. 3. The discount rate represents your opportunity cost. Choose it carefully and consistently. 4. Multiple tools exist for investment analysis. Payback period. Simple, but ignores time value of money. Discounted payback. Better, but still incomplete. NPV, the gold standard. Accept if positive, reject if negative. IRR, useful complement, but trust NPV when they disagree. 5. Always do sensitivity analysis. Test your assumptions. 6. In construction, these tools help you make better decisions about equipment, technology, processes, and projects. The bottom line? Good investment analysis separates successful construction companies from failed ones. Every dollar you invest should create value. If it doesn't, invest it somewhere else. Before we finish, let's do a quick mental exercise to test your understanding. Imagine you're the project manager and you're considering investing in a new concrete batching plant for your construction company. Here's the scenario. Initial investment, $500,000. Expected annual cost savings, $125,000 from not having to buy concrete from suppliers. Useful life, 6 years. Salvage value at the end, $50,000. Your company's discount rate, 10%. Your mission, should you choose to accept it, calculate the NPV and determine if this is a good investment. I'll give you a moment to think about how you'd approach this. How would you set this up? You'd discount each of the 6 years of savings, plus don't forget that salvage value in year 6. Then subtract the initial investment. Want to know the answer? Work it out and compare your calculations with your classmates after class.